Hello.
पाँच सेकंड बाद आपको होना शुरू करना
Hello. Very good afternoon to all. Myself, Dr. Ashwini Thakur, Assistant Professor in School of Basic Sciences, Avilashi University. And my area of specialization is physics. So, at the very outset, I extend my sincere thanks to Avilashi University and NDLI Club for providing me an opportunity to interact with you today on a very important topic, which is right over the screen. That is the first principle study on Heusler alloy, advancing spintronics and green energy application. So, the content of my talk is divided in mainly in a five subsections, which includes the introduction, functional materials and their need in the present era, Heusler alloys, the specific material which I am going to discuss about their potential, that how these materials can be used for spintronic as well as the green energy candidate. And next is the about the methodology, because if you claim that certain materials are very good due to its functionality and wide applications, so it means that the one has tested that particular materials at the various aspect, either maybe the experimentals or the theoretical. So, in that particular context, I am just going to give a brief idea about the methodology to achieve that, which particular methodology, and then the conclusions and some sort of the applications of that and future scope as well about the materials and this talk, whatever I have discussed in this section. Okay, so about the first thing is that about the introduction sections. So today the whole world is the strive for developing the materials for sustainable energy applications. Now we can see that the dependence of energy of the whole world, that is upon the fossil fuels, and other sources of energy are still in its underdeveloping phase or developing phase. So moreover, one more important thing is that why this concept of the energy, that is why energy dependency of energy is very harmful in the today geopolitical scenario. We can see the today's scenario that our dependency on the fossil fuels is about 80 to 90% on the Gulf countries, and we can see that the whole Gulf is in the war zone. So that it means that somehow up to today, we peoples or our, that is our research didn't develop such tools which can be provide alternative resource of energy. When I talk about the alternative resource of energy, it means that those sort of energy resource which are not exhaustible, or which are sometimes the renewable resources of energy, or we can say that non-conventional resources of energy. So in order to develop these resources, there is a demand, or there is urgency to develop the functional materials. for that to contain that, how these resources can be utilized. For example, we talk about the electric vehicles, which can provide a resource that is which alternative for the energy. And but for the electric vehicles, still we have the lots of obstacles are there regarding the battery, electromagnets, and all these things are there. Okay, so in this particular talk, I'm just going to propose the idea for the functional materials, that this type of functional material, which I have do the research on these materials since last few that is time. So that and I have that is I'm projecting that this particular material is going to be a alternative for the energy as well as the other functionality. So if we talk about the that is functional material, as I told you that the for sustainable energy we need to develop functional materials. So the functional materials are some short of those materials which having that is some specific applications or properties, like some enhanced magnetic properties, electronic properties, thermal properties, and optical properties, as well as for the various advanced technological applications. They are the major focus of that is global research to develop that is the functional material. Nowadays the researchers among the 90% of the researcher among the world, they are working on devising the materials. They are devising the materials. They are devising the material, functional material especially. So in that particular development, it is equally important to develop the next generations technology. That technology starts from the electronics to energy storage, the spintronics, the sensing, thermoelectric effects, functional materials also enables toward the enhanced performance, efficiency, and the miniaturizations of the devices. So we can say that it's not because why it is these functional materials are very important, because they touch they influence the every individual life. For example, we are using the smartphone, we are using the advanced laptop as well as the other devices. How these comes through? These comes through these comes from the functional material. So to devise for all that, not for the material researchers and for other for example the peoples who belongs to the chemistry background, or peoples from which are also belongs to the other category or as well. So if we look at the this particular picture, so this picture show the vast and the different applications, the perspectives of the functional materials, starting from the magnetic, electronic, thermal, optical. So you can see that every property of that particular functional material is associated with certain devices. You can see that ferrites are there, rare earth magnets, which are utilized in the electric vehicles, and other that is the windmills and the power stations are there. So thermoelectrics are there, which are utilized in harvesting the green energy. For example, just which I'm just going to talk in the coming slides. And optical properties, for example, that is we are using the ultra high definitions televisions with the high definitions, you can see that. So this comes from the functional materials. So this area of the functional materials and their application is very very vast. So it is not possible to summarize all these things, all the applications in a particular lecture. So moving concisely, so I'm just taking a few applications of the functional materials, which actually I have work that is since last many times I'm working over these materials with certain particular applications. But these are not the particular applications; these are the applications for the advanced technology. Okay, so these are for the advanced technology. So these in this talk I'm just going to discuss about the two major application, advanced application of this material. One is the spintronics and another is the thermoelectrics. Spintronics is that is the type of that is the field which is utilized, in which the spin is of the electron is utilized, and application of these spintronics is also influencing the life of an every individual. It's not for the researchers, it's for every individual. From a simple household activity, for example, the in a household activity we are using the various devices are there, like the smartphone, smartwatch, and that is the washing machines are there. They are also fitted with, they work on your fingertips. So how it is possible? This is possible with the that is a development of the that is a functional material. So about the spintronics, we in that is in context to the spintronics, it is also a very that is important application of the functional material, which touch every life, everyone individual life, where they are using the phone. Everyone is talking about the data that we our phones having certain high that is the storage capacity. So how this comes from? This comes from the advanced technology application, and that application is the spintronics. So another is the thermoelectric. Thermoelectric is another certain functional material advanced, in which some heat of the that is particular industry or whatever that is harvested for green energy applications, because in our daily life, might be you have witnessed that there are various things are there that where the heat is lost, that is in extra way. It means that that is not utilized, so that is called as the waste heat. So in that particular context, in waste heat, we can utilize that particular heat for the for certain devices are there. So now question is that which type of materials, functional materials. So there are the lots of materials are which may be the functional, as I told you that these functional materials perform the that is the various application, they having some certain special applications. So I'm just going to discuss, and that is the usual alloys. So usual alloys are the category, among the category of the advanced functional material, which exhibit a range of physical properties, applications in various technology important fields like magnetic tunnel junctions, spintronics, hard disk reads heads, spin valve generators, and magnetic random access memory cells, and thermoelectric devices which are used for the green energy applications. Okay, so about the usual alloy, why these materials are of great importance. So there are a certain specialty of these materials which is reflected in this particular slides. So why these are becoming the center of advanced research? Because they are ideal candidate for the spintronic and the green energy applications. So it has been proved experimentally as well, and also they are very good thermoelectric. They have very good thermoelectric response. They show a thermoelectric response. When we talk about the thermoelectric response, there are certain categories through which this thermoelectric response may be discussed. Next is the compositional and structural flexibility. They having the very good compositional and structural flexibility, greater stability, and synthesize easily at a room temperature. This is another very important aspect which the material should be, that the materials should, if the materials can be synthesized at room temperature, and importantly they exhibit the that is the same properties of importance at that particular temperature. So it means that these materials are of ideal material, or we can say that these are the materials of the advanced research. And next is the good magnetic and half metallic properties. So this is another important aspect for the these particular usual alloy, with that they show the that is the very important magnetic as well as the half metallic behavior, which might be seen by very few materials, which falls in the category of the functional materials. And next is the high Curie temperature at room temperature. room temperature. So that is a high Curie temperature means those material which sustained their properties at the room temperatures. So that like in context to the magnetic, just I'm just going to discuss these in my coming slides. So about the Heusler alloys. So Heusler alloy basically was devised by a German metallurgical engineer, and also he was a chemist in the 1903. Till that particular time, these materials for decades remains dormant, that nobody think about these materials. But the first research was comes on these materials, that was done by that this fellow, that is Friedrich Heusler and other, and that was done by the on the this is the copper 2Mn and Al. This is a very important material. Interestingly, that see that about the copper and manganese and aluminum, these that is the all these three materials are non-magnetic. But whenever they are combined in a particular composition, so they show the ferromagnetic properties. So this is undoubtedly attract the many researchers worldwide, that how it is that how can be done, that although the individual element of this particular composition, which is called as the alloy, is non-magnetic, but whenever they are combined in a particular ratio, they show that that is they show the that we have the ferromagnetic character. So in that particular context, this then after these materials become the center of the study. So they named according to their chemical compositions and structural order on their electronegativity, because alloy is basically those particular material which are that is the homogeneous, that is mixtures of two or more that is elements, homogeneous. And this alloys means they are following the Hume-Ruthre rule. It means that alloys can be made by in accordance with the Hume-Ruthre rules, where certain rules are there, which are the electronegativity is there, one factor is there, then we have the that is the atomic crystal structure is there. So in that particular context, then whenever a particular material is a fit on that particular scale of the Hume-Ruthre, then it becomes the that is alloy in that particular context. So this crystal structure of the Heusler alloy, it is well defined, and it with the general that is a chemical formula, which is X, Y, and Z. Where X and Y, these two that is the elements, they belongs to the category of the transition elements of the periodic table series, and whereas this Z belongs to the P block elements. Might be heard about all these things. So this the chemical compositions of these alloy, that is in a different stoichiometry. So that stoichiometry is in XYZ, X2YZ, and X prime or YZ. These are the three different composition. So based upon that particular compositions or the elements which are used, so they are named as a different. Few are the half, full, as well as the quaternary alloys. So these are the, I'm just in these slides there is the these are the different types of the user alloy, and these are the half full and inverse and the quaternary user alloy. And in this screen you can see on the right side, this is the crystal structure of the these user alloy. They show the crystal structure of face centered cubic crystal structure. So and a number of atoms are lying there, so different color representing the different the presence of the different atoms right over there. And in the bottom, that is the extreme bottom of this particular slide, you can see the periodic table. So and this periodic table, which the particular elements which are shown in the that is the D block elements. They this is what I said that these X and Y belongs to the that is the D block elements. Okay, so so with these particular compositions, the researchers around the globe taking these particular compositions and working and projecting these particular Heusler alloys as a potential functional material for different applications. Okay, So these are the Heusler alloys, and from these slides you can see that how this crystal, that is the structures of this Heusler alloy made to be, and these are the different crystal structures, and you can see that. These are the paramagnetic. These are basically paramagnetic materials, and these paramagnetic materials are you can see these are the paramagnetic, ferromagnetic, and ferromagnetic, or also called as a half metal. So Heusler alloys are popularly that is known as the ferromagnetic half metals. Half metals are there. So in a nutshell, we can say that from this particular figure we can see that here that these different particular parabola show the up spin and the down spin different electrons. In paramagnetic they are the same. It means that the spin polarization is zero, and for the ferromagnetic, that is it is the uneven. It means that for balancing the Fermi level, the energy levels for the upspin and the downspin electron, they will accommodate themselves accordingly, and in that particular context the electron spin polarization is less than 1. And for a ferromagnetic half metal, that they having the two different channels are there. You can see that different channel for one spin channels. For you can see for the up spin with the right red color arrow, this is what behave like a metal, and for the next it behave like a semi metal. You can see that the Fermi levels, the conduction band and the valence bands, they are lying very far. So it means that this is showing some that is half metallic property. So this property is the most fascinating behavior of this class of material, which I am just going to, which is I am talking about these particular materials. So with this particular formula is given here, this in terms of P is equal to D, this E Fermi. So this represents the density of states for the upspin as well as the for the downspin electrons. Okay. So moving forward, so let us, as I told you in that is previously, that functionality when we claim a particular material for its functionality, it's a very vast. So we have to concisely. So about the spintronics, as I told, that I'm just going to discuss about the spintronics and the that is the thermoelectric effect of this Heusler alloy as a functional material. So one is the spintronics. So if we just recap the certain ideas, that is when transistor was devised by Shockley and Bardeen. Bardeen and Shockley, they got the Nobel Prize for this one, and actually the whole electronic industry was revolutionized with the discovery of the this transistors. Might be heard about the transistor. So in that particular days, it was the idea, what basically the idea, that the motion of the electrons, which is primarily the main that is a participant in the in or in we can say in overall contributing the electrical as well as the thermal conductivity of a material, that these are known as electrons. Might be you heard whatever that is electrons. So that is what the spintronics, what electronics mean. Electronics means when you are just harvesting the mobility of electron only. Mobility of electron, it means that if electron is supposed to move, it leads to the electrical connectivity. It means that more is the mobility of electron, more will be its electrical connectivity. It's a simple thing is there. So based upon this particular idea, various devices was devised by the researcher around the globe, and at that time this particular idea was a very effective idea. But nowadays, when the technology becomes very advanced and different sophisticated tools becomes for characterization and all these things, so in that particular context, this spintronics means a spin-based transport. It means that spin is the that is inherent property of the electron. So it means that the spin of the electron is being utilized. So in that particular context, along with the spin, mobility is okay, but spin is also harvested. So On the basis of this particular spintronics, that is the spin, various devices are devised, and peoples are using them, and that is comes from the spintronics. So spintronics holds a great promise for improving the performance and energy efficiency of electronic devices, which is crucial for continued that is the development of the technology. Right, you can see from this particular diagram. So first, as I told you, that is a charged electronics, and another, this is a spin magnetism. So it means that whenever both, that is a charge, that is a mobility plus spin, both are combined, that it becomes the spintronics, spin plus electronics, and it becomes the that is, and it is used in the various devices like HDD, hard disk drive, as MRAM, and that is that is read head in the hard disk drive, and various other devices it may be used. So need for the spintronics, Murray was a very great that is researcher. They give a very pioneer law about the base electronics. He said that the number of transistors on the silicon chip will roughly double in every 18th month. It means that number of transistors are become, it means that the technology is advancing day by day. In that particular context, what we need a more, that is a component to be, that is this particular, that may be that is fixed on the particular silicon chip. So it means that it becomes overcrowded. So and electronic devices which are reaching increasingly small size, intense heat, and becoming a great problem. So that is becoming a great problem. So in order to get rid of the particular problem, so spintronics was provide a great alternative to get rid of that particular problem, to decrease that particular congestions of the component on the that particular we can say chip, we can say that or also the quantum properties of electron, that is a wave like properties of electron, that was also that is not studied in case of the electronics. So spintronics also harvest that particular property. So spintronic devices offer a possibility for enhanced functionality, higher speed, and reduced power consumptions. So okay. So another important factor, that is a green energy application. So green energy applications, about that Heusler alloy are also a great materials for using the thermoelectric applications, and these thermoelectric applications are also named as green energy application. It means that these materials as a functional component, they can be used or to harvest the waste heat. So you can from this particular figure you can see that there are the various aspect of that, from where this waste heat can be waste heat can be we can say collect or regenerated for and utilized for the various technology. For example, thermal power plant is there, nuclear power plant is there, vehicles, automobile industry is there. We can see that lots of heat is generated by the engine, and but this heat is not utilized again. So waste incinerator are there, for example factory glass are there, natural gas is there. When there is extraction of the crude oil, huge amount of heat is being created, so that cannot be utilized. Because why it is not utilized? Because we didn't devise the component which can be used to that particular that is to harvest that particular energy. So these are the primary energy, that is the sources we have. And that is you can surprisingly that is observe this thing, that 66% of the energy that is wasted in terms of heat. So this is the great in itself, that 66% is wasting in it. We don't have tools to utilize that particular for the regenerations of the as a green energy. So in that particular context, we have this crisis is persistent and getting worse day by day. So in that particular context, thermoelectric material have earned a great attention, as these are capable of converting the waste heat into energy, into electrical power. So consider as unconventional and green energy sources. So this is the most fascinating application of this usual alloy as a thermoelectric material, right? So now question is that how this particular that is materials can be utilized, that if somebody if is somebody is claiming that this particular material is the very good thermoelectric or which having the spintronic application, it means that we have go through certain technology through which we came to know that this particular material is behaving like this one. So for this one, there is the methodology adopted, and that methodology is the first principles calculations, which are very very important. First principle calculation means that from the scratch, from the initial, and this particular property, that principle involved just to devise certain materials or certain physical properties of material without considering its experimental values. So that is the first principle. So it means that first principle calculation or first principle methods go, that is ahead to the experimental. So it just provide a blueprint of the research or about the particular materials. So we can say in a nutshell, we can say it just provide all type of information about a particular material, that about its functionality, about its different and special properties to the that is experimentalist. This is the beauty of this particular, and that is with the minimum resources. But it is not possible, as we know that it is not possible for experimentalist to just to analyze all the material on a single scale. So it is very difficult. So actually this first principle methodology are quite, that is inspired from the quantum mechanics and the quantum mechanics of the many body system. We can see that this particular quantum mechanics, so that is the quantum mechanically we can say that the overall energy of a system can be the explained or defined as the sum of its kinetic energy, potential energy, as well as the interaction energy is there. So in the right you can see that in red the nuclei are shown of atom, and these are the blue dot, they are representing the electrons. So you can see that the interaction, in order to, it means that in order to understand a particular material, it is equally important to understand the interaction first. And if we do not understand the interaction, it means that we are lagging somewhere. We are not finding the exact property or exact behavior of that particular material which leads him or it towards the functionality, that is the toward advanced applications, we can say. So this particular slides gives you the idea of the that is the interaction. So the more this interaction is basically a more the challenge for the researcher, that how this interaction can be hold. A very that is eminent physicist as well as the researcher whose name was Born Oppenheimer, and he gave a approximation, that approximation leads that is the motion of the nuclei is very less as compared to the electron. So we can say that that is interactions which involve with the nucleus, they are being muted. So with this particular idea he go forward in order to explain the, that is a first principle calculations or methodology. So if this was the idea, we can say that, as I told you that this is H represent as the Hamiltonian representing the full sum of kinetic energy, potential energy plus interaction term. And this interaction is with the nuclear interaction. This interaction is with the electron interaction. This interaction is with the nucleus as well as with the electron. So this is very complex phenomena which is called as exchange interaction. So in that particular context he gave this particular equation, yes, that we can mute the that is the interaction which is claimed as witnessed by the that is nucleus. So moving forward, so with this particular method, certain methodology was adopted by the different researcher. One is a wave function, another is the density based function. This is a theory, or wave function based. This wave function based methods involves, that is Hartree-Fock, that is Hartree, Molar, Plesset configurational interaction methods are there. That is the So this involves a certain wave function based methods are there. So but this is the problematic, if we want to study a certain material computationally. So we can say that this becomes problematic, because it increases the cost of the it just computational cost. It is as a wave function based. So for n number of electrons, they are represented 3n, for that is three dimensionally. This psi, this wave function, which is the probability, that becomes the 3n dimensional. So but researcher then moves toward the density based method, and then that leads to a very important methodology, that is called as the density functional theory. So nowadays, that density functional theory was equally accepted, is equally accepted around the globe by the researcher, and they supposed to utilize it in order to understand, in order to execute the first principle, that is the results of that particular material, that is there having certain potential to that it may be utilized for, as somebody claim that it is utilized for the advanced application or not. So in density functional theory provide that particular way. So what actually idea, the basic idea that involves that this particular diagram show the two views of the Schrodinger view and the density functional theory view. So we can say that here electron interaction is shown with the nucleus. So and this particular that is the thick dark line is representing the external potential. But in density functional theory, this external potential is replaced by the, that is the effective potential. So it means that now we are not not considering as this particular method as a wave function. We are considering it as a density function, that every individual that is individual electron is the non interacting entity. So in that particular that is the theme, the whole density functional theory was devised. So the density functional theory provide a state of art computational approach to investigate the ground state properties from first principles methods. It is basically a quantum mechanical approach. This method was devised by that is Cohen-Sham and Hohenberg. They were the two Swedish researcher and scientists, and later Cohen got the Nobel Prize for devising this density functional theory in chemistry in 1998 year. Okay, so this was the Hohenberg theory, and this one Hohenberg Cohen theorem, that all properties of many body system are determined by the ground state density, that is n naught. So for the ground state, total energy E is a functional of this n naught r. So we can say that it means that this is all about a functional versus function. So this leads to various discoveries which we can just we can assess or predict a particular material on these particular density functional theory scale. So so for this particular approximation, we have certain tools, and that the information about these approximation that was given provided by the Jacobs, and in the form of Jacobs ladder. So that this is in this particular figure, you can see that ladder is there laying over there. This rungs of this particular ladder, they are representing the different approximation methods. So starting from the that is we can starting right from this particular bottom, that is the first rungs. So we can say that only method is only density is considered. Then after the density plus the gradient of the density is considered. Then after density plus gradient of density plus the kinetic energy is considered, and then it's moving forward, it leads to the Hartree-Fock method, and then it is the density functional theory. It What actually this particular ladder explain, it explained that with accuracy is increasing, but with increase in the accuracy, of as we moves upward in inside this particular this that is ladder or ladders or each rugs. So what happens that the computational cost is also increasing. So this might be that is, but accuracy is also increasing. It means that cost is directly proportional to the accuracy. So this works on this particular self-consistent cycle, and these cycles that represent as with the density functional theory. In order to predict the basic functionality of materials, we start with initial gas, and then we provide a particular gas a density, and then we calculate the electron density against that particular gas. If it is conversed, then it is a self-consistent. Converse, it means that if value is whatever we have give in initial gas, that is approximated it to its that to its value, it means that that is the self-consistent. If not, then we have to go toward the other iteration. So this is that's why it is called as the self consistent cycle. It means that we provide an initial guess what the actually this particular system with taking certain function it go that is and do calculation over it. If the results are close to a actual value, then it means that the system becomes self consistent, and it will gives you the output. Otherwise this particular iteration will goes on. That is with these many iteration we can just we can reach up to the that is close to its that is actual value. So this density functional theory about we have calculated certain results are there. These are the electronic structures and magnetism of certain materials which are taken in the form of Heusler alloy, that is x to y z की form में, जहाँ पे that is we have the x and y are the transition elements, and z that is a p block as I told you, and here it is aluminum. So as in the my previous slide, as I told you that the these Heusler alloy show the that is half metallicity, right? Half metallicity. So it means that half metallic means for spin up these the red arrow showing the spin up and the spin down configuration. So these are the results which prove them as the ideal spintronic material. Same for next we have. So we have about the magnetic properties. The magnetic properties of these materials are also in accordance with which put them in the category of the functional materials. And then it's a thermophysical response. These are also well established. We have calculated that is a specific heat at a constant volume, specific heat at constant pressure, and then we have calculated the its thermal expansions, and then thermal expansion. Along with that we have also calculated its entropy. All these results show that these materials is ideal for the spintronic applications. So moving forward, so we have the electronic that is the thermoelectric properties. So these thermoelectric properties are also in accordance with its the standard result that this particular material which are known as Heusler alloy, they may be utilized for the as material to that is to harvest the that is the heat or that is a green energy. So it means basic it works on certain basic principle. These are that is the Seebeck coefficient is there, figure of merit is there. So I all the values are that falls, they are the ideal, and they match that this particular materials is ideal for these potential applications in the field of spintronics as well as the thermoelectric behavior. So another important study which is performed, and that is the lattice dynamics that is a study which is called as a phonon study. So all we observe that there is all positive frequencies are there, which also put that proved that this particular material is ideal for the experimental synthesis. And yes, there is this application is okay, but it is also equally that is material, there is a possibility of its synthesis is there. Okay, so conclusion and future possibility. The conclusion is that the data that whatever the materials which we have claimed, and that is based upon the computational methodology, all the results, and they have been predicted well before towards the that is before the future experimentalists they may work on them to synthesize them in their lab, and then they just put them in the form of the devices. So this is the all about the that is the about the this particular materials, and well as the first principle calculations for the spintronic as well as the thermoelectric applications. Moreover, their application date starts, as I told you, from the magnetic, electronic, optical, and all these properties it covers. But need is there. It requires some expertise from the experimentalists, so that these particular materials can be synthesized in their labs. So with this one, thank you very much for your patience listening. Thank you.